Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over how to apply the power rule for derivatives. Don't forget to visit our website at math.serve.com for access to a wide variety of math tutorials ranging from algebra to calculus. To get started, let's take a look at what the power rule is for the derivatives. So let's write this down, the power rule. So if y is equal to x to the n, then the derivative dy dx is equal to n times x to the n minus 1. Okay, so all you basically do when you are applying the power rule is you bring down the power, you make it a coefficient of x, and then you subtract 1 from the power. Okay, n times x to the n minus 1. Before we apply this to some examples, let's go ahead and derive this formula, this rule real quick. Let's go ahead and derive it using the limit definition of derivatives, okay? So we know that the derivative of a function, let's say we have, so let's just title this the derivation. Derivation. All right, so we're going to derive the power rule here. Okay, so if y is equal to f of x, then we know that the derivative dy dx, the derivative of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. Okay, so this is the limit definition of derivatives. Now what we're going to do is apply this limit definition of derivatives to the power rule, to this situation right here, and see if we can end up with this as our derivative. All right, so for our derivation, let f of x equals x to the n. All right, and that follows that f of x plus h is going to be x plus h to the n. Okay, now let's go ahead and write down what the derivative is using the limit definition of derivatives. So dy dx of this function, actually we're dealing with f, so let's just say df dx. Df dx is going to be the limit as h approaches 0. F of x plus h is x plus h to the n, as we indicated here. X plus h to the n minus x to the n, that's f of x, and that entire thing divided by h. All right, so now let's expand this using the binomial theorem. So let's go ahead and write down what the binomial theorem is real quick, and then we're going to apply it to this to the expansion of x plus h to the n. All right, so the binomial theorem, if you remember this from algebra 2 or pre-calc, if we want to expand a plus b to the nth power, that's going to be the discrete sum from k equals 1 to n of n choose k, that's a combination. How many combinations of n choosing k at a time can you have? Times a to the n minus k, b to the k. All right, if I want to write this in expanded form, it's going to look like this. It's going to be n choose 0, that will be the first term, times a to the n minus 0, b to the 0, those two just drop off, so you just have a to the n plus n choose 1, a to the n minus 1, b plus, the pattern goes on, dot, 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 plus n choose n minus 1, a to a times b to the n minus 1, and then the last term is just going to be n, choose n, b to the nth power. Alright, so if we want to simplify this further, this normally comes out to a to the n, because if you compute n, choose 0, you're going to have n factorial over n minus 0 factorial, 0 factorial. You end up with 1. Okay, so this is just 1 plus n, choose 1, a to the n minus 1, b plus dot 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 plus n, choose n minus 1, a, b to the n minus 1, and then when you compute this combination right here, you end up with 1, and you have b to the nth power here. Okay, so that's how it normally comes out to be. Alright, so we're going to be applying this expansion to this piece of our limit definition of a derivative. Okay, so let's go ahead and make that application. We're going to have df dx is now going to be, let's make sure I have enough space to write this down. Alright, so remember the only portion that we are applying the binomial theorem to is x plus h to the n. So if we apply that to that situation, we're going to have x to the nth power plus n, choose 1, x to the n minus 1 h plus dot 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 plus n, choose n minus 1, x h to the n minus 1 plus h to the nth power. This entire expression right here is the expansion of x plus h to the n. Okay, so in this situation right here, instead of a plus b, we just have x plus h. Alright, so this is x plus h to the n, but we have to subtract x to the n, okay? So we're going to subtract x to the n, and then divide the entire expression by h. Let's see what happens here. You notice that x to the n and x to the n cancel out. Okay, and then we can factor out h from every single term that's left. So if we do that, we are going to have, oh, let's not forget our limit. Limit as h goes to 0. Okay, so we have the limit as h goes to 0. Factor out the h, we have h times, let's make that a bracket, h times, let's see, n, choose 1, x to the n minus 1. This h got factored out already, plus, let's just add on the next term. The next term is going to be n, choose 2, times x to the n minus 2, h. It's supposed to be h squared, but if we factor out an h, we're going to be left with h to the first power there, plus dot dot dot, plus, let's see, the last term we have here is h to the n, so, well, I can write this down too, so let's just put both of them. So we have n, choose n minus 1, x to the xh to the n minus 1, so h to the n minus 1, and then lastly we have plus. Now we factored out h from this term right here, so instead of n minus 1, if we factor out h, we're going to be left with a power that's decreased by 1, so it's n minus 2, and then this is going to be h to the, instead of h to the n, is going to be h to the n minus 1. Alright, so there you have it. And this entire thing divided by h. Now what's going to happen here is that the h's cancel out. This h right here will divide out with that h. Now when you take the limit as h goes to 0, every term with the h drops off. Okay, so this term goes to 0, this term goes to 0, this term here also goes to 0. And your final, the term we have left is just n, choose 1. You're going to be left with dy dx or df dx equals n, choose 1, of x to the n minus 1. Okay, if you do the calculations, you have n factorial over n minus 1 factorial, 1 factorial, x to the n minus 1, which is n times n minus 1 factorial over n minus 1 factorial, 1 factorial. This cancel out, 1 factorial is just 1. So you're going to be left with n x to the n minus 1. That is the derivative ddx of x to the n. Alright? So this is the power rule. Alright, now that we have derived it, let's go ahead and apply it to some examples.